Today's speaker is Martin Wegmann. He's the data steward for the natural sciences, and he will talk about README rules, the red flags, recommendations, and routines. So thank you, Martin. It's great to have you here.
Hello, everyone. Today's topic will be about what is a README file and why is it useful. And we don't have a lot of time, but this is the structure for today. Just 2 slides, like what it is and why it is, why it's important, why it's useful. Then we go through the title, alliteration, and then at the end, I want to show a little bit how it looks like here at the University of Bern for BORIS Portal if you actually submit data to BORIS Portal, which I would invite everyone to do. It's a really great data repository. Okay, what is it? A README file is, in general, a document that is providing essential information to other people to understand your software, your research asset, your data. And here I want to stretch that a future user could also be yourself. So if you come back from like your 3-week all-inclusive holiday, then you can use this document to also understand what you did yourself, right? But of course, first and foremost is for other users. And important contents are especially data provenance. Where is the data coming from? What's the history? What's the story behind this data? How was it produced, collected, invented, and who to contact? One especially important point that we like to hammer down on in the open science office is that whatever you write, make sure that other people can open the file. That's probably the most important point for today. And we recommend that it's to non-commercial and open format. So for example, a docx file would not be that. I'll come back to a second on what different formats could be. And also, it should be relatively close to your research asset. And I mean, like physically, virtually close to your research asset. So it should be next to the research asset that you want to share so that people basically stumble upon it automatically when they want to use your software, your model, your data, whatever. Why is it important? It's important for you also. Of course, it's nice for others to understand what's going on, but it's also important for you. First of all, it supports collaboration. That means more citations, more interactions, better network. And it supports that collaboration by guiding people towards what you did and yourself. It helps so that people really use the data, this asset, the software in the way they should use it. It prevents misuse and it also prevents a legal misuse. And that's important for yourself also. You want to, let's say, be cited. You want that certain parties don't use your data, certain parties do. That's information that you can write in a README and it protects yourself in a way. The README file can actually protect yourself. And of course, in the sense of open science, it increases transparency, what you do with the taxpayer money, and what the outcome is of your research. So a bunch of reasons why README files are useful and important for yourself, especially also. So we go through the first point, a red flag example. So here I ask an LLM, give me a bad example before I'll show you actually controversial examples from the real world. And this is, of course, this already has a nice structure, I have to say, a description, usage, a license, but what's written down is, of course, not sufficient at all. The description is meaningless. The usage is also meaningless. I mean, what does that mean? You can use it however you want. Great instruction. And the license, it just says it's licensed, which I don't know if I'm a user, I don't know if I can use it in which way. And can I like sue people? Can I sell the data? I don't know. The let's say the structure here is already quite nice. It has 3 essential points, but the content of these 3 points is completely useless. Then the next example would be from the real world. Here it says like, oh, this is an overview of the material, and the following document provides data used in this paper. And by the way, in all experiments, observers were required to indicate the number of lines presented. That's the whole README. That's the whole README. I just took a screenshot of that. Okay, so first of all, we don't have the nice structure that we had in the first example. Well, it does say like, okay, it's used in this publication, but I have no idea what this data entails. How can I use it? What's the license? What's even the description of the research asset, the model, the software, the data? So I don't even, okay, I have maybe the last names of the authors, but there's no contact information. Yeah, like I'm basically, it could also just not exist, this README, and I would be like, had the same amount of information basically. The last example is this README where it says, okay, here we coded this information and basically this is the variable in our data. This is the description of the variable, which is very nice. And then there's a note, which is also nice. But there's a lot of things missing, like the license, like how should I use it, like contact information also about the authors. And so I would say this is, even though it's nice that the variables are described and you have like a little note, anecdote about what's happening, I would still say this is a really incomplete README file. So what would be typical red flags that we could see from these README files? Number one is there was no contact information in none of those examples. And this is really an essential part of a README. Another red flag would be no description of variables. We saw one of those examples had that, great, but the others didn't. So actually, if they're coded in some form or shape, I have no idea what's happening. Oftentimes there's multiple files and they have cryptic names. And I have no idea, looking from just the file name, what is happening. So I have no description of what each file is about. This is definitely a red flag. No description of how the data was produced. Did someone look into a microscope, take a photo? Did someone use a smartphone to collect something? Did someone employ a sophisticated physical model that took 3 years to run on a supercomputer? And then finally, there was no license mentioned in none of these examples, and that's definitely also a red flag for a README. Okay, let's go to maybe recommendations now, the next chapter of our talk. Recommendations, and this is a very dry topic in the sense, but we still like these examples. So you see that they don't have any formatting basically. They're just ASCII text, and on the left-hand side you have the Contact Institute. It's University of Bern Astronomical Institute. You have multiple points of contact. So you even have an address, so you can physically go there, probably find these people, ask them something if the telephone doesn't work, if the email doesn't work. Then there's a chapter called processing strategy. So it actually tells the people this is what happened, this is what we did. So maybe there's some raw data, we did X, Y, that, and in the end we got Y. And on the right-hand side, this is the same README. It continues. There's some general remarks. There's a file naming convention. This is how we named our files. There's a year and a day of the year in this file. And finally, we have some format description and data records where it says like, okay, like this variable has this short name, this long name, this line describes that feature, etc., etc. And this might look not too fancy, maybe a bit boring. There's no colors, there's no bold text, no cursive text, etc. But this is really all that there is, and all we need to understand. So, looking at this example, what we can understand for recommendation, and I'm coming back to one of my first slides here. is that you want to use an open, non-commercial format. So usually what we recommend at the Open Science Office here at the University of Bern is that you use a text file, an RTF file, or a PDF file. These files can be opened with a bunch of products that are for free, a bunch of software, a bunch of operating systems, and no one needs to buy some software to open it, etc. There are also files that are file formats that are around for a really long time, and we can imagine them to be around for a while. Then another important point, especially in the world of academia, is that you list a long-term point of contact. What does that mean? So we oftentimes, when people submit to the data repository of the University of Bern, this might be a PhD student that is just about to finish and next year works for UBS or Helsana or whatever. And then the University of Bern email address will not be valid anymore, right? Or also like short-term postdocs that are there for a year, then they're gone to the US, to other parts of the world. So in this case, we usually ask people, please write down an email address that will be around at the University of Bern longer. Of course, there's no one that stays forever. But for example, the PI or a technician, like a IT person that has a permanent contract, someone like this. In addition, of course, in addition to the information of the original author, then please make sure you mention a license in the README. This is really important, again, to protect yourself, but also to make sure that other people understand how they can use the data. And you can always approach us about these license questions. File overview explaining the variables in the data. I already mentioned that in the red flags. Explain how the data was produced. And I think what's always nice for the next user is to state if there are any pitfalls in the data. So, for example, you can't trust this value too much because at that day actually there was a blackout in the power circuit, and this might be some weird data coming out of this. So if you need to reduce the data, this might be a first step to remove a data point or whatever. So things that and this is science, right? Like science will never be perfect, but you can mention these things there. Then this slide is for YouTube. Of course, you can also take a shot now and write down this URL, but you don't have to. This is the official template that the Open Science Office created for README file. So you can stop the YouTube video here and look at the QR code, look at the URL, but I'll just have the screenshots with me now. And this is a text file, and this is something that you can fill out, that you can modify. We obviously don't want everyone to fill out the whole thing. It's quite a document, so you can just delete things that don't apply for you, and then fill this out in the best of the way you can. So it's a title of data set, contributor information, date of data collection. Maybe it has a geographical location. You picked some flowers in your mom's garden, then you write down mom's garden, right? Some keywords. And then on the right-hand side, you have licenses, you have links to other assets of yours that use that data. Maybe a publication uses this data, etc. You can also write down, which is really nice for you, a recommended citation for this data set, and then you would start listing the files and the variables, etc. So you can have a look at this template yourself in peace and quiet, and then you can modify it the way you want it. Again, this is just a recommendation, not a mandate. Finally, the last point of my alliteration routines. Once you created a data set, there's a couple of things that you could update in your README. For example, you might find bugs in your data, then you can write that down. There's, for some data sets, softwares, etc. You know this from the App Store. Whenever you get an update for an app, there might be version changes. So you can write a new README and say, like, in this version, we changed that and that and that. If you move to a new place, you could update the contact information, and maybe you write a couple of papers based on the same data set. So you can list the several papers that you published using that data or using that software or using that model or whatever it is. These are just some things that, yeah, you can help future users with these information as well. Last point I want to make is how the Boris portal workflow would look like. So if you log in on Boris portal and you go to your dashboard, then you have this point on the top right here, add research data. And if you click on that, you come to a mask that guides you through this uploading process. You see on the left side of your screen now, like description, relations, clinical studies, upload license, etc., etc. This is like kind of the process to upload data on Boris portal. And if you come to this point of upload, where it's actually about uploading your data, you see that we say, please upload your research data files and documentation. And there's a link again to the same README file template, once in English, once in German. And if you would submit a research data set without a README file, we would contact you and ask you to actually still do a README file. So it's kind of a soft must. You don't need to use this template. You can come up with your own stuff, but we do not allow any more data sets without a README file on Boris portal. And yeah, you would just upload a README file together with whatever data you want to upload. We have a quick look if it makes sense, if there's enough information in there. And then we are happy to accept your data set on Boris portal. So that's all there is for me today. This is the contact information. If you have questions about licenses or the whole workflow, then you can write an email at researchdata@unib.ch, and we are here for all your questions. Thank you.